Hi kids, welcome to our fifth lesson in chapter 7. We've been talking about systems of equations and solving them, and today we're going to talk about what happens when something strange comes up, when we have been solving correctly, doing our math right, but what happens if things don't quite work out right, and what does that mean? But before we jump in, just know I'm going to do my best to hit the highlights, and this is hopefully good for my students who have been absent or need a refresher, some homework help. It's not going to be perfect. It's not what every math teacher would do, and that's okay. Each one, has their own strategy. So hope this is helpful for you, though. Okay. So let's look at two different examples of strange things that might come up. One will be the whole front page and one will be the back, just to keep it organized for you. And also it's going to follow the same structure too, so you can kind of keep organized this way. Let's say that we are attempting to solve the system of linear equations, and you can do that in a variety of ways. You can do substitution and combinations. You could do graphing if you really wanted to, right? But let's just say I'm going to use combinations and multiply this by, a negative 1 to get the equation now negative 2x minus y equals positive 1. And I'm just going to bring this guy over, keep it lined up. Maybe you don't do yours like this, but hopefully by now you've kind of established your own kind of procedures, the way you do things. Okay, and so I did that so I could cancel out my y's. But wait, I can also cancel out my x's. That was quite by accident, but that's weird. So now I have nothing on this side equals 6. The number for nothing is 0. Is 0 the same as 6? It's not. Okay, so that's a problem, and so that's something that makes us go, huh? So let's see, since we can solve by graphing, let's see what happens if we were to graph this. So let's put both of these in slope-intercept form. So y equals negative 2x plus 5. So there's about 5. My lines didn't print correctly. We're just going to estimate, and that's okay. So that's this line. Okay. So now we're going to do the same with the other line, and hopefully we find an intersection so we can find what's going on here. Do the same, get it in slope-intercept form. Minus 1. Okay. So there is my intercept, and up to, wait, that sounds familiar. The last one had a slope of negative 2. Do you remember, it's been chapters ago, when we learned same slope for parallel lines? Parallel lines have same slope, perpendicular lines are inverse and opposite. Yeah, these are parallel lines, and we can see that they run parallel. Well, the point of solving a system of linear equations is we're finding the intersection point. But parallel lines never intersect. So therefore, there's never going to be a coordinate that satisfies both of these equations. So this is an example of a no solution. Let's summarize this at the bottom in a place where we can kind of refer to it later. So once we wrote these in slope-intercept form, we made the observation that we had the same slope, and which created parallel lines. They're going to rise and run at the same rate. And parallel lines never intersect. That's their definition. So because the system of equations, the solution is where the lines intersect, and lines with the same slope never intersect, so there's no solution. There's no point that will satisfy both equations. So the most important part for you to remember is this. If two equations written in the same form have the same slope, they make parallel lines, and so therefore there's no solution. Okay? Great. That's not so bad, right? Okay, let's talk about another strange situation here. So here's another system that might confuse us if we were looking at it. Again, we can solve this any old way that we want. Let's just say I'm going to keep with the, what do you call it? Oh, combinations again. So let's say I'm going to, let's move this. So plus 2y plus 2y, so negative 4x plus 2y equals 6. So now I'm looking at these two. Let's cancel out these y's. So I'm going to multiply this top one by negative 2. And you can do this your own way, and you will get the exact same result. All right. And I'm going to bring this guy over just to keep them lined up so I can kind of focus. Sometimes I have things going on in too many places and I just can't keep it all in line. Okay, so the point of that was to cancel out my y's, which I did. The same thing happened again where I canceled out my x's, but look, I also canceled out my constants. I canceled all the things out. Well, how can I solve something if I just canceled the whole thing out? Nothing is nothing. Well, of course we knew that. That almost looks like a face. Boop, boop. Anyway, let's investigate further. What happens when we graph these? This gives us a little bit of context. It seemed to work last time, so let's see what happens here. So y is 2x plus 3. See, we all wondered why we had to learn how to rewrite equations in slope-intercept form. Here it is again. Everything we're doing is so cyclical. It's a blessing and a curse, right? Okay, so there's the red line. Let's try the next one. Ooh, I'm gonna have to move this guy all over the place. I want y's to the right. And x's to, no, y's to the left. X's to the right. Maybe I shouldn't record these late at night. And that needs to be by itself. So y equals 2x plus 3. Well, wait a minute. There's my intercept at the same. Can that be? Is that possible? Let's look at this. As we see here, when I rewrite this equation, it becomes the same. And so this is one way to write it. You know, you can rewrite an equation in a lot of different ways. I will also add here when I wrote these in slope-intercept form, which is what I highly recommend that you do when you're solving them your own, right? Write them in slope-intercept form so you can look at them closer that way. Whoops, lost my page. So anyway, either way you do it, when you line up your x's, your y's, your equals, and your constant, you're going to get the same equation. And if you have the same equation, you're going to have the same line. Okay, now because the solution for a system is where the two lines intersect, and if this is just an endless intersection of a line that goes on forever, there's an endless number of solutions that would satisfy both of these equations. So that means any point on this line would satisfy both equations. If I picked this point, 0 and 3, it would satisfy the equation. If I picked this point, 1, that would be 5. That would satisfy both equations. If I did that all the way up the line and all the way down, it would satisfy both equations. So, again, because the solution of a system of equations is where the lines intersect, and lines with the same equation are a constant intersection, there are infinite solutions. That sounds very cool, right? Infinite solutions. And to state it in a very simple way that's understandable, if we end up with the same equation they make the same line and infinite solutions. Okay, great. Okay, well, let's look at our practice. This is definitely one of those lessons that becomes way more manageable once we've done some practice. More than others, I feel like this is a good one to just jump in. Okay, I would like to give you some help before we even get started. When you're doing this, just write things in slope-intercept form. Write everything in slope-intercept. Can't talk. Write everything in slope-intercept form. Y equals mx plus b form. If you do that with everything, that will help. Okay? All right, so this first section is matching. So again, once you write these in slope-intercept form, you'll match them with the options below. So for example, this one would be y equals 2x plus 1. This would be y equals 2x minus 3. So now that they're in slope-intercept form, I can see that they have same slope, so they're going to be parallel lines. That could be both of these, so I need to choose one. Well, this one has an intercept at 1 and negative 3. At 1 and negative 3, and a positive slope of 2. So I know that A goes with number 2, or 2 goes with number A. You can do that either way you want. And then I should also write here that there's no solutions. This is a no solution situation. Great. And so you can do that with the other 5. All right, down here, I would like for you to tell how many solutions the system has, again, by writing in slope-intercept form. First. Okay. So, for example, this one would be y equals negative x minus 1. Y equals negative x plus 8. Same slope, different intercept. So what are these? These are also parallel lines, which will never intersect, so this is a no solution as well. Okay, great. All right, for this next section, I would like for you to use the graphing method. So again, write these in slope-intercept form, then graph them on your coordinate plane. Remember to number them, please. Find the solution, if there is a solution, and then please write here if this is 1, none, or infinite solutions. Okay. All right, there's some word problems we will talk about in class, but for now, I think that's enough challenge for the moment. If you get stuck, please do not hesitate to send me an email. Oh, what is my email? Rochelle.net. Don't be bashful. I wouldn't give you my email address if I didn't want to hear from you. Otherwise, I will see you in class. Thanks, guys. See you later. Bye.